Welcome to the Banauli film series at the eve of Muharram. Get the blessing of Allah, and I am Peck, physicist visiting Banauli film series. And today I am going to discuss about the general theory of relativity and prediction based upon it. So let's start. Einstein's special or restricted theory of relativity is based upon the assumptions that the law of physics have the same form in all frames of reference moving with a constant velocity with respect to one another. For example, inertial frames. Later on, Einstein extended his theory to include the accelerated motion also and hence to describe the gravitational phenomena. His first postulate of general relativity tells that the law of physics can be expressed in equations having the same form in all frames of reference regardless of their relative motions. The second postulate of general relativity states that no experiment performed in a closed laboratory can distinguish between the effect produced by a gravitational field and those produced by an acceleration of the laboratory relative to stars. And this postulate is known as the principle of equivalence. For example, consider a man were inside a closed elevator car in outer space, and if the car were suddenly accelerated upward, he cannot decide whether a gravitational force had pulled him downward or the car had been accelerated upward. The general theory gives the following prediction which have been tested experimentally. First, consider a ray of light is bent by the sun's gravitational field. During a solar eclipse, a star near the sun appears to be displaced at some other distance. This is because the light from the star passing near the sun is bent in sun's gravitational field. The observed magnitude of this displacement agrees with the value predicted by the general theory within about 10%. Second example, there is an advance of the perihelion of Mercury's orbit. The planet Mercury revolves around the Sun in elliptic orbit with Sun at the end of its pocket. The point of the orbit at which the planet is nearest to the Sun is called the perihelion. The perihelion itself is found to be very slowly rotating around the Sun at a rate of about 2 degrees per century, so that the orbit is changing. This effect is called the advance of the perihelion of Mercury, whereas more than 99% of the observed perihelion advance can be explained as due to the gravitational attraction of the other planets on Mercury. The remaining residual advancement can only be explained on the basis of general theory of relativity given by Mr. Einstein. Next examples, a stationary clock runs more slowly in a strong gravitational field than in a weak one. An atom emitting light of a definite frequency is equivalent to a atomic clock. This third prediction means that the light emitted by an atom on a star must be of frequency lower than that emitted by the same atom on Earth. In other words, the light from the star must be shifted toward the red end of the spectrum apart from any Doppler shift. This effect is called the gravitational redshift. The gravitational redshift has been actually observed in the spectral lines of certain stars called white dwarfs, and also in a laboratory experiment involving Mashabar effect and verified the prediction. So these are the examples of general theory of relativity. And now my heartiest congratulations to the Muharram. So with this I would like to tell IFAC physicist, you should get the blessing of Allah. Thank you very much for watching my this movie, the general theory of relativity and its prediction based upon it. Thank you very much for watching my movie. So with this I would like to end this movie at this point. Thank you very much and a nice welcome to you. So my heartiest congratulations to the Maharam. Thank you very much. Thank you very much.